Um, Hi, I'm Matt Hall. I'm one of the Agile Geoscience people here, and I'm going to be talking about geology today. Striplog is a small new package for sort of playing with data that instead of being a sort of regularly sampled continuous set of data like we often use in the subsurface, like a wireline log or something, it would be irregularly sampled and have some qualitative aspect to it, so sort of qualitative mixed in with quantitative data. And this is something I built specifically for a particular piece of work. It's one of those things where maybe it's slightly over-engineered for that particular piece of work, but it seemed like something that would be at least fun to build and hopefully even continue to be useful. And indeed, we have used it in another project. In fact, I think we've used it in 2 other projects since then, so, you know, win. So what the heck do I mean by this sort of irregularly sampled interval data? Well, as you probably know, geologists really like dealing with rocks, and when we look at pictures like this, as geoscientists, we tend to sort of immediately chop it up in our minds into pieces, so that in this picture here, there's a kind of hard rock on top, and then some shaly stuff, and then a big thick package of a channel system in this case, and then a bunch more shale with a few really thin little beds in it. So these strata or beds, multi-scale things, and which bits we're interested in and how we describe them might vary a bit depending on the application. But that's basically the idea, is I'm interested in capturing where these things are in space and what their properties are, their internal properties. So it might come from field data, like I just showed you. It might come from something like core data, which is something we often collect in economic geoscience and for research. And then the geoscientists are going to pore over those cores and describe them in sort of with a various sort of degrees of technology. So sometimes they'll be like drawing it on a piece of paper and then getting it digitized maybe. Sometimes they'll be actually putting it into a computer right away. But we don't always have software necessarily for this kind of task, and we don't always have data that comes from an era when there was software for this kind of task. So we have data that's come from this sort of modality that, you know, spans back probably almost 100 years in some places. Anyway, this is a sort of product of an exercise like that. We might have depth or sometimes elevation down one side, or, you know, that's the sort of domain that we're in. Then we might have something like age data, and then we've got these sort of beds or strata that I was talking about. And then you can see where the sort of qualitative stuff creeps in, because the descriptions are usually written in English, or sometimes with somewhat semi-standard abbreviations, mixed in exclusively. It really varies. As I say, they can be quite old. Here's one from the 60s, but the language is actually fairly invariant. Here's one where there are applications, many applications, where we'd like to have our funky interval data, it's like side by side with or in the same domain as some semi-continuous or more continuous, but still ultimately discrete data. So we'd like to be able to do some sort of data integration exercises. And ultimately, we're heading for, building cross-sections of these things as sort of 2-dimensional transects through the Earth, where these data would provide those little stripes, called Striplogs, hence the name of the package, the little stripes that we get there at each profile. And then they've been interpolated with varying degrees of geoscientific wisdom guiding the interpolation. So for this particular piece of work, which was for the Nova Scotia government, they actually had already, quote unquote, digitized some of this data by basically drawing them in CorelDRAW, which, is kind of digital data, but you can't really sort of do anything with it. And one of the tasks that we were sort of posed with was getting that into a format that we could do all that cool integration stuff and so on. So we had a big stack of PDFs to extract so they basically look like those things I showed you earlier with the handwritten descriptions, and it goes from 1629.3 meters to whatever, shaly sandstone. And that meant actually getting them transcribed. We did that in the end mostly in a service called Elance, where you're basically getting human beings to do those tasks for money. That, you know, we thought about trying to do character recognition and all this kind of thing. It's totally impossible, as far as I'm concerned, in human timescales. So we sort of gave in and did it with humans. And then to take those hand-drawn strip logs that I just showed you and make those into real digital data that we can use, and reproduce those hand-drawn strip logs. But you know, if I want to change my sandstones from sort of light brown to dark brown, I'm pretty stuffed if I've done that in CorelDRAW. I've got to go through and change them all. But of course, programmatically, that'd be easy. And then one of the sort of parameters of the project was that we didn't want to use a database and risk kind of building something that no one ever touched again, essentially. So we chose to do everything in ASCII files. There's a standard in, at least in oil and gas, called the log ASCII standard, or LAS, and that was going to be where we were going to store everything. So text files, basically. And we'd also like to do some cool things, as well as all this kind of just data grappling. So the package I built has basically starts with the concept of a component. I originally called it a rock, but then I thought, well, actually, this could be anything. It could be a fossil, it could be a time interval, it could be a sample from the lab. It doesn't matter in principle. All it's going to have is a bunch of attributes. So let's stick with rocks for now. Let's say it's a red sandstone and it's finely grained. And then out of those components, we can build intervals by basically just giving them a top and a base. And that interval might also have an English language description that goes with it, as well as having one or more of these components. So why would it have more than one component? Well, it might have some subordinate lithology. You've got a gray sandstone with some shale chips in it, for example. And then those intervals I can build up into a strip log, and I'd like to do some nice things like plot those. So there's a little bit of sort of extra paraphernalia around all this. I mentioned the descriptions already. Well, if I take something like that sentence, fine red sandstone with greenish shale flakes, on the left there, I'm going to need a way to turn that into some structured data, into a little dictionary of attributes, basically. You know, I'm dimly aware of natural language processing, and there's probably super awesome ways of doing that with machine learning. I basically just built this, what I call a lexicon. It's basically just a Python dictionary that says, here's all the words that are colors, here's all the words that are rocks or lithologies, here's all the words that have to do with grain size, that kind of thing. And then I use regular expressions to grossly pass through the descriptions and build these little structured entities. It's definitely going to be super fragile for anything other than what you designed the lexicon for. So, and essentially any task will need to have a new lexicon built. And the NLP approach, sort of NLP machine learning approach, is something I'm really interested in. If anyone has ideas, I'd love to talk to you about it. I've already had some cool conversations here about at least trying to build the lexicon somewhat automatically from a corpus of core descriptions, for example. And, oh right, and then at the other end, in order to plot something, you need to know, essentially you need a legend to sort of say, well, a red sandstone is going to be this shade of orange or whatever. So I have this concept of a decor, which is basically how to paint a single component, and then the legend is just a whole bunch of decors. Okay, I will briefly show you some of this extremely exciting stuff in action. It's really not very visual. I apologize for how unvisual it is, but so essentially I'm just going to pass in a dictionary here. So I'm doing this literally sort of by hand, saying, okay, here's a component or a rock. In this case, I'm going to build this and sort of instantiate it. And then we can do sort of handy things like build little English language descriptions out of those things with a little format sort of code. So that kind of thing could be useful for sort of putting a description next to all the elements on one of these painted Striplogs, for example. But really what I wanted to be able to do was take a little mini sentence like grey fine sandstone and using my lexicon turn that into one of these components, right? So that way I'm going to be able to take a spreadsheet with 200 sheets in it, and some of these things might have 2,000 or 3,000 English language descriptions in them from all sorts of geologists over all sorts of years describing rocks. And I want to essentially be able to standardize, if you like, the language and pull out these rocks. I had a lot of fun. This was actually, just like anything else, probably for a lot of us, I can't speak for everyone, but for me, these exercises are huge learning exercises, a big learning curve for, like, in this case, packaging, which was a real adventure for me. But this is also the first time I've really, like, deliberately sat down and written everything object-oriented. And I had a lot of fun with finding these magic methods that you can put on classes to make them into, to give them order, for example, and tell Python what you mean by this one being larger than this one, or by two things being equal. So there's a method in there to compare these little dictionaries and decide if the rock is the same or not. I'm not sure why I put that bit in there. That was completely boring. Right, so now we've got these components, we can build an interval by giving it a top and a base. If I ask for an interval for something where it says, like here, grey sandstone with black shale flakes, it'll treat that with as a delimiter for subordinate components and say, okay, that's a secondary component. And there's a few words like with and contains and new sentences that will tell the lexicon, okay, make a split here. Quite often you'll find things like 80% sandstone, 15% shale, 5% gypsum. It'll treat those as separate components as well and sort of find the proportion as well. And then those things get used in the construction of these little summaries too. So the striplogs are the most interesting bit. So what I'm doing here is actually just taking this is just a PNG taken from CorelDRAW. So we want to turn this into one of our structured things. So do that by just reading the image file. And of course, it doesn't know what the rocks are without the legend. So we've had to give it a legend and say the pink stuff is this gypsum, for example. So as long as we give it the legend, we can give it a certain amount of tolerance to recognize colors, so they don't have to be exact matches. And then it'll basically just go through and build that striplog by taking some pixels out and examining them, comparing them with the legend colors. And then we can make nice plots of those, but of course these are now matplotlib things, so we can label them and scale them and do whatever we like. And of course they know what they contain. It's all sort of semantic and nice. Funnily, so I literally at the weekend I added this thing called prune, which says basically takes out all the things that are thinnest, some percentile or below some thickness, in this case meters. And it was the first thing I wanted to be able to do when I built this package, because I've been looking for something to do that for ages. And so this was like my first use case, and I only just added it. But I can do that now, take these things out gracefully, and then I can anneal back into the gaps, basically, and fill them back in again, and end up. So it's a way of sort of thinning the data, and I think that's everything I wanted. Oh, there's a few things like finding words, finding rocks. You can go through, 1,000 wells and say find every time it mentions anhydrite. What I kind of like is that all of these searches and things send back striplogs, so you can plot everything immediately, and you can do all the things you can do on normal striplogs with the results. And yeah, there's more of these sort of little magic functions and things like it's super easy to make a histogram of all the lithologies in a striplog and all that kind of thing. So yeah, I think that's almost everything I wanted to talk about. I mean, this is just some of the stuff that you can now do, is like make a cross plot and color everything by lithology. And this is one of our other use cases. If anyone was in the GIS Birds of Feather earlier, I was asking about like 3D GISs where you can do subsurface spatial things. This was an attempt we made to gather arbitrary geophysical data onto transects and project them onto a plane in the Earth. But we use Striplog over here. So thank goodness we took care of that bit. Yeah, so anyway, it's in part, I hesitate to say, yeah, just go use this thing, but I mean, of course, it's seeing use that's going to help figure out what it needs to have. It's Python 2.7 and Python 3 installable. It only has 2 dependencies, and you can pip install it. Oh, this was just some, I'll let you look this up later if you want to, but basically just some useful things that I found trying to get my head around packaging and 2.3 compatibility. Those are the dependencies, hardly any. I really like all these like Travis CI and Codicy is something I've been using to kind of keep an eye on PEP 8 compliance and security and all these other things. It's just nice to be able to say to the client, you know, this is fairly tight code and here's our test coverage and all that kind of thing. That's me. You can get hold of me if you find any of this remotely interesting or fun. I'd love to hear from you, and that's everything. Thank you.